Let's look at how to take a given function and find the average rate of change on an interval. So first, let's start with an interval where we're given a numeric value for a starting point and an ending point. What we need to do first is find the outputs that go with each of these inputs. So we're saying from x equals -1 to x equals 3/2, what's the average rate of change on this particular function? So essentially what we're doing is we're taking this curve, so this is a quadratic function, so it would be a U-shaped graph. We're finding 2 points on that U-shaped curve and finding the slope of the line between those 2 points. So if we're finding slope, we need to have an input and an output for the starting and the ending point. So the first thing I'm going to find is f of -1. So I'm going to take -1 and plug it into my given function. So -1 squared minus -1. So we have 1 plus 1, which gives us 2. Now do the same thing with 3/2. So f of 3/2 is 3/2 squared minus 3/2. So we have 9/4, so 3 squared is 9 and 2 squared is 4, minus 3/2. You can let your calculator help when you're working with the fractions like this, or you can think common denominators. This is like 9/4 minus 6/4, so this is equal to 3/4. So our average rate of change formula is essentially just our slope formula is all that we're doing here. So we'll start by taking f of 3/2 minus f of -1 all over 3/2 minus -1. Another way to think of this is essentially you're just doing y2 minus y1 over x2 minus x1. So that may feel more familiar as your slope formula that you've used in the past. So we just calculated f of 3/2 to be 3/4. F of -1 we calculated to be 2 all over 3/2 minus a -1. I'm going to go ahead and write that as a plus 1. Again, feel free to let your calculator help you out with the fractions here. 3/4 minus 2, we have a -5/4 on top. 3/2 plus 1, so 3/2 plus 2/2 is 5/2. So you can think about dividing fractions as the same as multiplying by the reciprocal. So dividing by 5/2 is like multiplying by 2/5. So those 5's cancel and leave -2/4. We'll go ahead and simplify that and write that as -1/2. So what we're saying is if you were to graph this function and plot those 2 points, the slope of the line between those 2 points would be -1/2. So what if we keep the same function, but we change our interval to now be from 2 to some other value, and we're just going to call that other value a. So we start out with the exact same plan, find the outputs. So f of 2 is 2 squared minus 2, so 4 minus 2 is 2. F of a is just going to be a squared minus a, so we're just replacing the x's with a's. So using our average rate of change formula, we're going to take f of a minus f of 2 all over a minus 2. So we found f of a was a squared minus a, f of 2 was 2, and on the bottom a minus 2. So now we have a variable expression in the numerator that we can factor. So this is a trinomial. When we're factoring trinomials, we think about things that multiply to -2, the constant term at the end, and add to -1, the coefficient on the middle term. So two numbers that multiply to -2 but add to -1, this factors to a minus 2 times a plus 1. So you can check that by foiling. So do your firsts, your outsides, and your insides, and your last. Check that it matches up with our original trinomial. All over a minus 2. Now that it's factored, you're allowed to cancel the common factor of a minus 2, which leaves us with a plus 1. Be careful not to cancel terms on that original expression that we have. So it can be tempting to cancel the a or the minus 2, but you can only cancel factors. You can't cancel individual terms that we had in that first fraction. So you have to factor first, and then you can only cancel things that are multiplied times another factor. Let's look at one more version with this same function. So given the function still x squared minus x, let's look at the interval from 3 to 3 plus h. So we'd start with f of 3 is equal to 3 squared minus 3. So 9 minus 3 is 6. And then we need to find f of 3 plus h. So this is going to be 3 plus h squared minus 3 plus h. So when we see a binomial squared, we need to actually think about writing that 2 times and foiling that out. If it helps, you can also imagine a -1 in front of that second term here. So as we multiply this out, 3 plus h times 3 plus h, 3 times 3 is 9, plus 3h, plus 3h, plus h squared. And then distributing our -1, we're going to have minus 3 and minus h. We can combine some like terms here, so we have an h squared. 3h plus 3h minus h gives us plus 5h. And then 9 minus 3, we have a plus 6. So, coming to our average rate of change formula, we have f of 3 plus h minus f of 3 all over 3 plus h minus 3. So plugging in what we just found, we have h squared plus 5h plus 6 minus 6 all over 3 plus h minus 3. So there's some like terms that we can combine in the numerator. If you have a plus 6 minus 6, those will cancel out. In the denominator, the 3 minus 3 will cancel out. So we're left with h squared plus 5h all over h. You can think of this in a couple different ways. We could factor in the numerator and factor out an h from each of those terms since they have that in common, which leaves h plus 5. And then that h from the numerator cancels that h from the denominator to get just h plus 5. You could also think of this as 2 separate divisions. So you could think of it as h squared over h plus 5h over h and divide each of those individually. H squared divided by h gives us h. 5h divided by h gives us just 5. So you can either factor and cancel the common factor or think about each term in the numerator being divided by that single term in the denominator. So here our average rate of change is a variable expression since we're starting at a known value 3 and then moving over some distance h. So we're going from the points 3 to the x value of 3 plus h, that the average rate of change would be h plus 5. Since h is a variable, then our average rate of change will still have a variable as well.